In this video, we're going to look at solving systems of equations using the substitution method. And these examples, both equations will already have a variable isolated, the same variable isolated. So if we look at number one, we have y equals negative 2x minus 5 and y equals 4x minus 5. What I want to notice is that both equations already have y isolated. So you want to think of it this way. If you have, let's just say A, if two things are both equal to A, then those two things must also be equal to each other. All right, and although that kind of might sound either overly simple or overly complicated, what we're doing here is both of the equations are equal to y. All right, so this piece here is equal to y, and this 4x minus 5 is equal to y. So what I can do is I can set those two pieces equal to one another. All right, and again, the reason I can do that is because they're both equal to y. So from here, you're just solving an equation as you normally would. I'm going to add 2x to each side. So I get negative 5 is equal to 6x minus 5. And then I'm going to add 5. So I get 6x would be equal to 0, divide by 6, and x would be equal to 0. So that's the first part of my answer, but I do need to figure out what y is. To do that, I'm going to take where x is 0, and I can plug it back into either equation. It doesn't matter which one you pick. I'm going to choose the second one just because there's less negatives. It should be a little bit easier. So I'm going to do y equals, I'm going to look at the equation y equals 4x minus 5. So y equals 4 times 0 minus 5. Again, that 0 is being plugged in for x. So y would be equal to 0 minus 5, and y is equal to negative 5. Most times you want to write your answers as a coordinate point. So this piece here and this piece here, we're going to write my answer as, or our answer as 0, negative 5. All right, remember, x comes first and then y. So taking a look at number 2, same thing's going on. Both equations already have y isolated. So I can take this piece here, 3x minus 23, and negative 2x plus 17, and I can set them equal to one another. Doesn't matter which one goes on the left and which one goes on the right, as long as they're equal. So I'm going to solve this by adding 2x to get my x terms on the same side. I would then add 23. 5x will be equal to 40, divide by 5, and x will be equal to 8. So what you're going to find is that you'll always solve, the first variable that you find will be the one that has not already been isolated. So if y was isolated, you'll wind up solving for x. So I'll now take that x equals 8 and plug it into either equation. Again, it doesn't matter which one you pick. I'm just going to use the first one. So I'm going to use 3x minus 23. Sometimes one is clearly easier than the other. Sometimes it's just a matter of which one you pick. There's not a right answer. So y would be equal to 1. And once again, write your answer as a coordinate point. So we're going to say 8, 1. Let's just fix that y. That should look a little more like an x. Or no, I'm sorry, a little more like a y. So y is equal to 1. You'll notice in these 6 examples that y is always the one that happens to be isolated. It's just the way that these problems are set up. If x is the variable isolated, you would solve it the same way. All right, you would take the two pieces, so these two pieces here, and you would set them equal. So it doesn't matter that it's y equals. If it was x equals, so let's just pretend this was this instead, you would still do the same thing. You would just take the two pieces and set those equal to each other. All right. So this is the first part of substitution. There's 2 other types of problems that we'll look at in the next set of videos, but you're taking the pieces that are equal to the same variable, again in this case y, set them equal to each other, solve, and then make sure you solve for both variables. All right, you're not just stopping once you found x, you also need to solve for x and y.